Dear friends, this lecture is devoted to sampling, and this is the second lecture on sampling. I have already talked about basic concepts of sampling, and in this lecture I will talk about more types of sample designs. And in the last lecture my discussion was focused on two things: simple random sampling and standard error. And in this lecture I will be discussing other designs of probability and non-probability sampling. I will also touch upon sampling in qualitative research and theoretical sampling. As you know that in sociology we use two types of methodologies, quantitative and qualitative, and in both types of researches we need sampling. Quantitative researches are based on surveys, experiments, observations. In sociology, however, experiments are less. I am not much familiar with experimental studies in sociology in India, except one, the famous Khanna study, in which efficacy of certain family planning methods was tested in field situation. Actually, experiments use the concept of experimental and controlled subpopulations. I have done some studies in which we wanted to test the impact of rural development programs such as self-help groups or Manrega, and though strictly speaking they cannot be called experimental studies, but we took a sample of self-help groups and a corresponding sample of those women who are not part of self-help group, but have similar socio-economic background, and compare the two groups with respect to economic conditions, awareness and other things. Surveys are more common, and in survey we make a list of questions or interview schedules, go to respondents, either distribute questionnaires or talk to them using interview schedules. You know them, methodology. You also know that certain studies are based on observations, and in all these studies it is difficult to go for census, complete enumeration method. We always depend on surveys. So, census is only one, I should say population census of India, which is conducted by Registrar General every 10 years, but otherwise most of the studies of government, universities, NGOs, research organizations and PhD students and MA students like you are based on sample data. In qualitative researches also samples are used. Qualitative research is one in which you deal with subjective meanings or actors' perspectives by putting yourself into the shoes of your subjects or respondents, by spending a lot of time in the field. It includes ethnographic studies, studies of court cases. Those who use ethnomethodological methods, they have studied court cases, coroner's classifications, and the attempt is made how the respondents or subjects or people construct an order in a word which is seen to be without any order. Harold Garfinkel says that order is not an objective entity. Order of any kind, order in consciousness, order in behavior, order of social structure, they are actually constructed by the people in a given setting, in a given context, and outside that context that structure of consciousness makes no sense. So, the concepts of reflexivity and indexicality, etc. Now, sampling in quantitative research, as I mentioned in the last lecture also, there are two types of sample designs. One is called probability sampling and another is called non-probability sampling. Probability sampling, the advantage is that you not only get estimate of the variables in which you are interested, estimate of income, estimate of consumption expenditure, estimate of knowledge, estimate of attitudes, what proportion of people, for example, are in favor of family planning program, etc. But you also get an estimate of precision of your results. This is a unique advantage of probability sampling. In non-probability sampling, you get only estimates, but you cannot make a statement about precision of your estimates. Now, precision is defined technically and we will talk about this in this lecture, but non-probability sampling can only give you an estimate. Sometimes results obtained from non-probability sampling may in fact be better than the results obtained in probability sampling, but the main advantage is that in case of non-probability sampling, no theory of estimates can be made. Theories of estimates have been made only for probability samples. Sometimes we may also use mixed or complex designs. For example, I said that in multi-stage sampling, we may use different types of sampling choices at different levels of sampling, and that if the ultimate purpose is to reach women at the grassroots level in different parts of the country, you may choose states first. At the national level, you choose some states which can be done in a simple random manner or in a purposive manner according to some criteria, according to some needs, policy requirements, or it may be decided by the government that when they sponsor research to some university or research organization, they tell that we are interested in working in these particular states. And then within those states at the district level, you use simple random sample or other types of designs which we are going to discuss today. At the block level or at the level of urban wards, you can use a third choice. You can maybe you use simple random at the district level and you use probability proportional to size at the block level or at urban wards level, and then within the villages you can again use simple random sampling or systematic sampling or some other procedure. So, you can combine or mix various types of designs in your sample design. Probability sampling is again divided into a number of or types of sample designs. Random sampling is one, you call it random sampling or simple random sampling. Then stratified random sampling, systematic sampling, cluster sampling, and other designs including multi-stage sampling. We will talk about all these things one by one. Random sampling, I have already defined. Random sampling is one in which you make a complete list of all the units in the target population. This is called sampling frame, and if you select some units from the sampling frame, a definite proportion of units from the sampling frame, then ensure that probability of selection of all the units in the target population is same. Any method which ensures that probability of selection of all the units is same leads to simple random sample, which is also called random sample. It is different from incidental sample. In incidental sample, you do not assign fixed probabilities. It is by chance that when you visit the field, units which may be easily available to you can be interviewed. That is incidental. Some people, because in incidental also if it is unplanned, then researcher is not deciding which units to be selected. So, many researchers call incidental sampling as incidental random sampling, but strictly speaking incidental sampling is not a random sampling. Random sampling is one in which you assign equal probability of selection to all. What is stratified sampling? In short, stratified sampling means that when you are dealing with a heterogeneous population, you may like to divide the whole population into a number of groups or strata, which should be homogeneous within and which should differ from each other as much as possible. Means you divide the whole population into a number of homogeneous groups which are different from each other, and then from each substratum or each group, each homogeneous group, you select a certain proportion or number of samples by using simple random method. That is stratified sampling. When subpopulations vary considerably, means overall population is very heterogeneous, it is advantageous to sample each subpopulation stratum independently. And when you resort to simple random sampling in different strata independently, your selection, your choices in the third subgroup or subpopulation are independent of your choices in the first subpopulation, then this is called stratified sampling. Stratification is the process of grouping members of the population into relatively homogeneous subgroups before sampling. Like it may be done on the basis of caste or income or religion or urban rural or age groups or gender. You may want independent samples from men and women, rural and urban areas, from different religions, and with the expectation that the respondents within these categories are more or less homogeneous, and between these categories there is maximum variation. The strata should be mutually exclusive. If a unit belongs to one stratum, it should not belong to any other stratum. That is the meaning of mutually exclusive. So, all the target units, all the sampling units in the target population belong to one and only one stratum. Why do we do this? Obviously, such a sample, logic, common sense suggests that such a sample would be more representative of the population. This often improves the representativeness of the sample by reducing sampling error. In technical terms, it will reduce sampling error. I have already defined sampling error. We will talk about this a little bit more. It basically means a standard deviation of your measurements which may fluctuate from sample to sample. It produces a weighted mean that has less variability than the arithmetic mean of a simple random sample of the population. So, if you are calculating average of some kind, say average income, average age, average education, then the estimate of mean or average from stratified sample may be seen as weighted mean of estimates from different subgroups, different strata, and that will have a lesser variance than the variance of mean in case of simple random sample. So, that is the advantage. But there are different strategies for drawing a stratified sample. How do you decide how many sample units be drawn from different strata? I will mention only two such strategies. One is proportionate allocation. It uses a sampling fraction in each of the strata proportional to that of the total population. This will be a simple thing to do. You can decide, see different strata will be of different sizes, number of men, number of women, number of people in urban areas, number of people in rural areas, they will be different. But what can be fixed is that from each subpopulation or each stratum, you will take a certain percentage of sample. If you want 10% sample from the entire population, you will take 10% separately from each of the subpopulations or strata. That is called proportionate allocation. So, proportionate allocation uses a sampling fraction. Sampling fraction means sample size divided by population size. This can be fixed for population as a whole and also for different strata in the population. In each of the strata, you take the same sampling fraction proportional to that of the total population. Optimum allocation. This is a good thing, proportionate allocation. It makes sense when you take the same fraction from all the strata. It should result in a better estimate than in simple random. But sometimes you face a problem that cost of sampling may also vary, from stratum to stratum. Not only size of sampling units varies, but also heterogeneity and the cost of sampling. So, if cost of sampling also varies significantly from one stratum to another, then you may like to go for optimum allocation or disproportionate allocation. Then you do not fix that from each stratum you will take 10% or 2% or 5%. Sample size from each stratum is then proportionate to the standard deviation of the distribution of variable in the stratum, which means how heterogeneous a stratum is. If stratum is more heterogeneous, then take a bigger sample. If stratum is less heterogeneous, it is more homogeneous, then you can afford to take a smaller sample. When we go for blood tests, very few cc of blood is taken from our body, because blood is homogeneous, and it actually does not matter whether you take blood from any part of veins, from hands, palms, legs, chest, the results would be same, results of sugar level, results of cholesterol levels, results will be similar. So, you take a small sample. When something is homogeneous, you take a small sample, but when the population is heterogeneous or a stratum is heterogeneous, then you have to take a bigger sample to do justice to heterogeneity in the stratum. And size of the stratum, bigger sample from bigger strata, smaller samples from smaller strata, and indirectly proportional to the square root of the cost of sampling per unit in the stratum. What it means is that you take a smaller sample from those strata where cost of sampling is high, and a higher sample or a higher fraction of sampling from those strata where cost of sampling is less. Why square root? That is a mathematical aspect of it. Thus, larger samples are taken from strata with the greater variability, greater size and lesser cost of sampling to generate the minimum sampling variance. In proportionate allocation, small nh divided by n. Small nh is size of sample from hth stratum. I have taken this formula from Cochrane's book, which is a very simple book for even beginners with some basic idea of algebra or mathematics. You can follow Cochrane's book, and it deals with simple as well as advanced topics in sampling theory. Actually, the sampling theory is about precision of estimates under different designs. So, this small nh by n means in hth stratum what proportion of units you are taking. Sample size in hth stratum divided by small n means total sample size. Capital NH is size of population or subpopulation in hth stratum divided by capital N. Uh, so, population in the sample in Hth stratum is in the same proportion to capital NH as the sample size, overall sample size is to population. If Hth stratum has 30% units in the population, 30% of the sample should be drawn from this stratum, that is the meaning. In case of optimum allocation, situation is slightly different. Because in optimum allocation you are also considering the variance in different strata, which may vary from one stratum to another, and also the variations in the cost of sampling. If you want to minimize cost of sampling under this situation, for a desired level of variance of estimate, or if you want to maximize variance of the estimate for a fixed cost of sampling, total sampling, then you can go for optimum allocation. And this in optimum allocation, small NH by n means from Hth stratum what proportion of units you will take in your sample is capital NH, capital SH divided by square root of CH divided by sigma capital NH, capital SH divided by square root of CH. Why this formula? That is beyond the subject of sociology. No great mathematics involved in this. You require some training in mathematics and in probability distributions to arrive at this formula. Let us take this formula to be granted. Again, Cochrane's book presents this formula, and according to this formula you can see that small NH need to be high. If capital NH is high, means stratum is bigger, capital SH is high, means the stratum is more heterogeneous, and less if CH or cost of conducting sampling in Hth stratum is high. High cost, this CH comes in denominator. So, high cost less sample, low cost high sample. There is direct relationship of small NH with capital NH and capital SH, but indirect relationship or opposite relationship, inverse relationship to be more precise. NH has inverse relationship with the square root of cost of sampling in Hth stratum. This is same for all. Advantages of stratified random sampling are many. First of all, it reduces selection bias by stratifying population before going for SRS or simple random sampling in terms of the criteria used for stratification. You see, while talking about SRS, I had said that although the probability of selection of all the units in SRS is same, but there is always a possibility of getting an extreme sample. In stratified sampling, when population is already divided into a number of homogeneous subgroups and you are taking samples from different subgroups, then the possibility of drawing extreme samples is avoided. Then you are taking some unit from this part, some units from that part, from all parts of the population you are taking units, and in that case your sample will not be extreme. It cannot be extreme. It will contain members of all castes, communities, gender, etc. It focuses on important subpopulations, but ignores irrelevant ones. You can do that also. If some subpopulations are not important for you, you need not take a sample from that or take a very small sample from that. But if some populations, some subpopulations strata are more important for you, you can draw bigger samples from there. So, irrelevant units can be ignored. Then it improves the accuracy of estimation. Improve the accuracy of estimation means that the standard error of the estimate. Estimate may be proportion, estimate may be mean, estimate may be correlation or regression coefficient or anything. Accuracy of estimation will be higher in case of a stratified random sampling. Then estimation with a desired precision from selected strata is possible. You may want your results to be of greater precision from some strata than from other strata. Actually, this point is quite related to the second bullet. If you want that from certain, you are more focused on certain strata, you want results of higher precision from there, but you also want some results from others, then you can use this stratified random sampling. And because of improved precision, obviously stratified sampling would need a smaller sample, where there is a trade off between precision and sample size. So, if you are able to improve your precision in stratified random sampling, then you can afford to take a smaller sample from there. There are some disadvantages of stratified sampling also, otherwise we will always use stratified sampling, but it is not so. Sometimes advantages of other sample designs or advantages of simple random sample may be more. One biggest disadvantage I would say is that you need to identify each and every unit in the population, but this applies to simple random sample also. You need to prepare a sampling list, sampling frame, but here something more is required, and that more part is that you need information about the variables of stratification. You not only need a complete listing, but you also need more information about variables according to which you are going to stratify your population. Then it requires accurate information about the population. If your variables of stratification are not proper, then it may introduce some biases in the results. And that relates to the point that sometime when it is difficult to select relevant stratification variables, how do we stratify population? Which are the variables which are closely linked with our study variables? If we are not able to identify those variables, or data are not available on those variables for the population, means you cannot identify subpopulations on the basis of that, or you wrongly identify subpopulations, then the results may be poorer than results obtained from simple random sample or other types of sample. Then sorting individuals into strata may also not be easy. Groupings of people on the basis of stratification variables may not be easy. Not useful when there are no homogeneous subgroups. Suppose your population is such that in all parts of population you have heterogeneity, then the stratification does not help, and of course, such a sampling can be more expensive than the simple random sample or other types of samples which we are going to discuss. For example, cluster sampling, it is stratified sampling would be much more expensive than cluster sampling. Now, some tips in selection of stratified sampling: determine the size of the smallest subgroup in your population. For example, if you want to look at males versus females and there are fewer females, then this is the group you want to look at, and then calculate the number of people required to achieve your desired error level and level of confidence for this subgroup. Calculate what percentage of people that you will need to survey within this group, number of people to survey divided by total subgroup size. Okay. And finally, calculate the number of people in each of the other subgroups that are needed to achieve the same ratio, same sample fraction for other groups, multiply the percentage from step 3, this is step 3, by the size of each of the other subgroups. This is how many people you will need to survey within each group can be determined. I was telling that estimate of mean or proportion from stratified sampling would be better than estimate from simple random, and that magic lies in the formula for mean of stratified sample. You see, mean of stratified sample will not be calculated as sum of all the sample values divided by total sample size. No, for each subgroup you will calculate mean separately, and then this overall mean y bar overall for the entire sample, mean of stratified sample y bar ST, this is called, would be a weighted mean of means in different subgroups or subpopulations or strata. The weight is capital NH or size of hth stratum divided by capital N. So, because this y bar ST depends on different estimates in different strata and strata size in relation to population size. So, this y bar ST is much more dependable than simple y bar or mean of all the values in the stratified sample. You have to be careful about this aspect. Many times you say in your research method that you are using stratified sampling, but then you finally when you calculate mean or proportion, you forget about stratification. That is wrong. If you have used stratification, then calculate mean of stratified sample as weighted mean of different estimates from different strata by using this formula. Very important. If you, I think this is one of the most important things I would like to emphasize, that if you go for stratified sampling, then calculate mean in this way and not a simple mean. Cochrane's book also shows that variance with optimization, optimum allocation is less than the variance of proportionate design and is less than the variance of simple random sample. So, in terms of precision, simple random sample has less precision than a stratification with proportionate allocation, which has a lesser precision than stratified sampling with optimum allocation. Next sampling is systematic sampling. Systematic sampling is a modification of simple random sampling. To arrive at a systematic sample, we calculate the desired sampling fraction. For example, if there are 100 patients of a particular infection in which we are interested and our budget allows us to sample say 20 of them only, then we divide 100 by 10 and we get the sampling fraction of 5. Now, this is called sampling interval. So, what it means is that you divide 100 units into 20 subgroups, each of 5 units. Then from the first 5, 1 unit is selected randomly. You can call it random start. Actually, this term random start or the term sampling interval, they are used in national sample survey studies at the village level, where you make a house list and then take a small sample from all the houses in the village. How? The NSS head office will send you random starts and random sampling intervals for all the villages, and suppose they say that random start is 9, then from the house list 9th person is selected as the first unit of the sample, and if sampling interval is 10, then 9 plus 10 19, 19 plus 10 29, 29 plus 10 39. So, 19, 29, 39th units from the house list would be your other sample units. This is what it means. So, out of first 5, 1 unit is selected randomly. Theoretically, this is the position, but practically in many circumstances, both sampling random start and sampling interval are sent from the head office. Head office will be careful in choosing random starts separately for separate villages in such a manner that ultimately no bias is introduced. It cannot happen that in all the villages you take third unit from the housing list first. In some villages it will be first, in some second first, in some third first, in some fourth first, and so on. Thereafter, we go through our sampling frame, selecting every 5th patient in this example. 100 patients, we want 20. So, we make a list, or we may not make a list. We visit patients in lots of 5. From the first lot, one patient is selected randomly, and for other patients we just keep on adding sampling interval and means 5. So, every 5th, when you take every 5th, then you are able to select 20 out of 100, like this. You are selecting 4 out of 12. Sampling fraction is 12 divided by 4, 3. So, from first 3, 1, 2, 3, 1 unit is selected randomly. This unit is suppose second. It may be first, it may be second, it may be third, but the randomly selected unit from first 3 is second. So, this is 1 unit in the sample. Then next 3, 4, 5, 6. From this group also only second units can be taken. In systematic sampling, once you have taken second unit from the first group of 3, then from second group of 3 also you take second. Then third group 7, 8, 9 again second, and then from the fourth group 10, 11 and 12 again second. So, thus 2, 5, 8 and 11, these units of the population constitute your systematic sampling every third. This is every third. Advantages. Advantages of systematic sampling are many. It is very simple. Yeah. Any interview in National Sample Survey can be said that take this, first make a house list according to some rules from which direction to which direction, etc., etc., and then from the house list take start from here, random start, and then every this unit 10, 15, sometime these intervals may be in fractions also 7.8, 10.9. So, suppose your random start plus interval is 20.7, then you can take 21st unit like. Then sampling frame is not required sometimes, where sampling frame is a problem. You cannot use simple random sample, or you cannot use stratified random sample. Imagine that you have to take certain fraction of trees in your sample for some testing in forest department research. So, you may be interested in 1/10th or 1/20th or 1/50th of all the trees in the forest. You need not make a complete list of all the trees, just identify a fraction like 1 in 20. From first 20, you take a random sample, it may be 6th or 7th or 8th. So, suppose it is 8th, then 8th, then 28th, then 48th and so on till you are able to exhaust all the trees in the forest. Extremes are excluded certainly, when you are covering the entire population, then extremes are avoided. That is an advantage, but there are some disadvantages also. One disadvantage is that systematic sample can give you biased results if there is circularity in the units, and This is a theoretical term. It means if similar types of units appear again and again in a circular fashion, then the results obtained from a systematic sampling may be biased. Then it is also difficult. Theoretical derivation of standard error of results obtained from systematic sampling are difficult to assess. Now, third sampling is cluster sampling. Cluster sampling is similar to stratified sampling. Here also we divide population into groups, but while in stratified sampling we divide population into groups which are homogeneous within and which differ from others. In cluster sampling we make groups of heterogeneous units. We make such groups that each group contains as much heterogeneity as the population contains. So, in each group there must be people belonging to all genders, caste, age, income, religion, whatever be your variables of interest. This cluster sampling involves dividing the entire population into clusters, each representing the universe. And then while in while in stratified random sampling, you draw samples from each stratum. In cluster sampling, you draw samples of clusters themselves. And since all the clusters are more or less representative of the whole population, it does not matter which cluster you select. You select 1, 2, 3, 4 depending on your needs and resources, some clusters, and study all the units in those clusters. So, selection of one or more clusters randomly or otherwise in a probabilistic manner or non-probabilistic manner. It is commonly used by treating contiguous geographical areas as clusters. All residents of selected villages, for example, constitute one cluster. So, while in simple random sample of rural households in a block, you have to have separate listing of all the households having certain definite characteristic, maybe income class or something, or wealth quartile. Class is formed according to quantiles of wealth. But in clusters you can treat villages or hamlets as clusters, choose some clusters and interview all the units in those villages or hamlets. Certainly, it reduces cost and time. This is a big advantage. If you are not selecting units from the entire population divided into some subgroups, but you are choosing only some parts of the population and studying all the units of those parts, then the cost and time is much reduced. But you require a bigger sample. This is called design effect. Design effect is defined as variance of estimate for the sample design that you are using divided by variance of the estimate for simple random sample, and a design effect of say 4 will mean that if you need a simple random sample of size 20, you have to take a cluster sampling of size 80, 20 into 4, 80. So, that is called design effect, and you have to keep in mind the design effect. Advantages and disadvantages. Advantages are that it cuts down on the cost of preparing a sampling frame, which is sometimes very difficult, very difficult to prepare a sampling frame, and in systematic you do not require a sampling frame. In simple random and stratified you need a sampling frame, and it is a great difficulty in survey research. But in systematic or in cluster sampling you do not require a sampling frame. This can reduce travel and other administrative costs. Once you have selected some villages, then an investigator has to spend more time in those selected villages, and the time and resources spent on traveling from one village to another will be greatly reduced. But there are some disadvantages also. One disadvantage, that sampling error is higher for a systematic sampling than the simple random sample of same size. Often this cluster sampling is often used to evaluate vaccination coverage in EPI. Okay. Vaccination is one example that for this kind of studies, for operations research, for evaluation, monitoring and evaluation of development programs, and for evaluation of vaccination programs, like you can use cluster sampling. And since you do not have to be very accurate, you are interested in knowing whether vaccination is as low as 30 or it has reached 75% or more. You are not making a small distinction, fine distinction between 30 and 31 or 31.3 or 31.4. So, there for evaluating vaccination coverage, cluster sampling may be okay. Then quota sampling is a non-probability sampling. In this method, a definite quota is fixed for different subgroups in the population, which reflects the proportion of the subgroup in the entire population, and it requires a good understanding of population composition. It is comparable to stratified random sampling with proportionate representation. Like if we are selecting people belonging to different caste groups and we know their overall proportions in the population, we can use this same proportions to select samples from different castes. Like we can take around 15% from scheduled caste, 7.5% from scheduled tribes, like that. Advantages of quota sampling are several. Quota sampling is less costly. A quota interview on average costs only half or a third as much as random interview, but we must remember that precision is lost. So, you save on money and time, but you lose in precision. It is easy to administer. The labor of random selection is avoided, and so are the headaches of non-contact and callbacks. Some people may not be available at the residence when you are going to interview them. What do you do? So, non-contacts. If field work has to be done quickly, perhaps to reduce memory errors, means you implement a program and immediately you want to see what is people's reaction, then quota sampling may be the only possibility. For example, to obtain immediate public reaction to some event, like GST, we are talking of GST. Recently, a few days before, some changes in GST have been made, taxation rates have been reduced, and you want to have a quick survey of what are traders and others' reactions towards this. You can go for quota sampling. Then quota sampling is independent of the existence of sampling frames. So, that is another and very important advantage of quota sampling. Again, like any other design, it also has some disadvantages. It is not possible to estimate sampling error. It is a non-probability sampling with quota sampling because of the absence of randomness. Some people argue that sampling errors are so small compared with all the other errors and biases that enter into a survey, that not being able to estimate standard error is of no great disadvantage. However, one does not have the security though of being able to measure and control these errors. Let me tell you that if you are going for simple random sample, then even for a very large population as of India, you hardly need a sample of size 400. So, if you go for cluster sampling with a design effect of 400 into 4, you need a sample of 1600. Beyond that, there may not be an improvement in precision. But of course, if you are measuring so many variables, then you have to look at other things also. Where will subpopulations with these characteristics be available and so on. Some sample design is not such an easy thing, but I am saying that you always need a small sample. You do not always need a sample of size 50,000, 60,000 or in lakhs. So, if you have some tentative understanding of what sample size would give you precise estimates, then you can take a bigger sample from that and use quota sampling, that is certainly more convenient. Then the interviewer may fail to secure a representative sample of respondents in quota sampling. Yeah, you may not be able to meet the quotas. For example, are those in the over 65 age group spread over all the age range, etc. You may not be able to get, you fix your quotas in advance. Strict control of field work is also more difficult. That means that did interviews place respondents in groups where cases are needed rather than in those to which they belong. There is always a problem of studying your own population, own culture. M.N. Srinivas has spent a lot of time on problems in studying own culture. If the researchers or interviewers have a tendency to focus more on respondents who are similar to them, that can also result in biased results. Now, sampling in qualitative research is slightly different. It is not based on estimates of various kinds as in probability sampling or quantitative research. It is not possible to fix a sample size in advance in qualitative research. Sampling in qualitative research basically follows one rule, and that is that you start collecting your data, and whenever you find that now you are getting the same or repetitive results, you stop. So, you do not fix sample size in advance, or you do not fix any sample design in advance. Maybe you can take help of quota sampling if you have an idea of that population is diverse. Nobody prevents you from taking some kind of quota sample in qualitative research, but in qualitative research what is more important is a priori determination of what kind of community or tribe or society or organization needs to be studied. Originally, by using qualitative research, anthropologists, sociologists use small pre-literate societies, but these days industrial organizations, corporate houses are also being studied by using ethnographic research. One of my students is studying masculinities in corporate sector by using qualitative ethnographic research methods. So, that is there, but in that case also you have to decide a priori in what kind of community you are going to do research. You can make a complete collection from a particular category, like you can choose to study women workers of a selected factory. If you are not interested in men, then you can ignore them. In qualitative research, we often focus only on extreme cases or deviants, abnormals or typical cases. We may also ensure maximum variation sampling, means all types of units be included. You decide that we are doing a qualitative research, but we will include all these types of units in the sample because they are different and we want reactions of different groups or communities to issues that are at hand. Intensity sampling, intensity of features, processes, experiences. You may like to study say earthquake victims, but intensity of problems or victimization may vary from one subgroup to another, or the process of victimization may also vary in earthquakes, in floods, famines, rehabilitation programs, big dams, and you can choose where you will intensify. Critical cases, convenience sampling can be used, and secondary selection. Basically, you decide what kind of communities and what kind of features you want to study. There is no sampling error, there is no estimate of mean or proportion, you may not even be interested in numbers. Start collecting data from the population where you want to focus, and continue as long as you are getting something interesting, novel, different, and when you start getting similar types of results, then you stop. This is the rule of sample size, a simple rule that we will follow in qualitative research. In some research, you may go for theoretical sampling also. Theoretical sampling, nowadays this term is very common, and in several departments of sociology where qualitative research is used, theoretical sampling is followed. It refers to the process of data collection for generating theory, whereby the analysts jointly collect, code and analyzes their data. There are special coding techniques for qualitative research, and decide what data to collect next and where to find them in order to develop their theory as it emerges. This process of data collection is controlled by the emerging theory. Suppose your theory is that you are studying religion, and your theory is that you use Talcott-Parsons theory or other theories, functional type, Malinowski, who say that religion is rooted in uncertainties, in meanings, in crisis, births, deaths, puberty, or in accidents, in various types of uncertainties in life, or when people are in miserable condition, poverty, crisis, or economic crisis. So, you will take a sample of people who are suffering from crisis. Theory will suggest that focus on those people who are in critical situation. But suppose you have another theory that religion can be found among those who are deprived of something, or who are victim of injustice or uncertainties of life, risk, threatening situations, and also among those who are happy, who have achieved success, who are happy, contented with their life. Then you need samples of both the kinds. So, actually theory directs what type of sample you should collect from the population. When in sampling you are directed by the theory and you are following qualitative research, then you are using a theoretical sampling. Like I may study that in India marriage age is changing, and I may also hypothesize that it is changing according to education. So, obviously, because my theory suggests so, I would like to have data from different educational categories of men, women, parents, and so on. Example of theoretical sampling is hospital services, various types of hospital services where you want to survey. You may survey, maybe researcher wanted to study services that minimized patient awareness, neurosurgical service for example, or where dying was quick, ICU, or like that, or where death was unexpected and rapid, emergency unit. So, deciding cases on the basis of theory leads to theoretical sampling. Thank you. Actually, sampling is not a routine part of research. I would repeat, I would like to tell you that sampling is not a routine part of research. It needs to be planned carefully, because your results are ultimately going to depend a lot on what your sample design is. Thank you.